Product and product design. Product designers conceptualize and evaluate ideas, making them tangible through products in a more systematic approach. Their role is to combine art, science and technology to create tangible three-dimensional goods. In this lesson, we will discuss product design and process selection, which are crucial areas in operations management. It follows from the previous slide that after studying this lesson, you should be able to define the topology of products, know the operation management in manufacturing and service sector, define design in the context of operations management, identify the objectives of the design activity, know the types of production system, know the important product design and architecture, learn about the product development strategies. Operations management is fundamental to an organization's achievement of its mission and competitive goals. It is involved in creating value in the products. Products can be tangible or intangible. Tangible products are called goods, while intangible products include services and contracts. These are collectively referred to as products. The difference among the product, service and contract can be understood by the table shown on the screen. As shown in the figure, product development includes a number of processes in identifiable stages. The first step includes clarification of the task. The search for ideas starts based on the new product strategy. The ideas that fit in with the strategy have to be identified. The customer needs need to be determined. This should provide pointers towards the functional requirements of the product. The specifications are the basis for concept generation. At the concept level, the organization should identify essential problems and propose the function structure of the product or service. Then comes the embodiment design. The ideas, after they have cleared screening, are developed in their preliminary configuration and an introductory analysis is conducted. Detailed engineering design stage involves engineering a detailed definition of the product, including its components, materials, sizes, shapes, etc. Concurrently with the development of detailed engineering design, physical evaluation is carried out. This includes fabricating a working prototype of the product as well as testing and evaluation to confirm that it represents the solution. With a new regime of patents and legal protection against copying ideas, designs or products, there have been changes in the approach to new product development. Being able to design, develop and introduce a new product quickly is a major competitive advantage, and it gives a firm fast-to-market capabilities. Companies employ two strategies for the purpose, viz. Fast to customization and fast to design. The first step in developing a new product strategy is that the organizations should decide their target customers, what they value and the likely size of the market of their interest. Product architecture should establish three things, viz. Specify the functional capabilities of the product, its features and post-sale servicing needs. Specify the capabilities of the product delivery system and post-sale support that the customer expects and determine the ability of the organization to provide for these. Specify the roles and risks each player within the supply chain will assume. Engineering economy is the discipline concerned with the economic aspects of engineering. It involves the systematic evaluation of the costs and benefits of proposed technical projects. Operations management is interested in enhancing value. Cost reductions often translate directly into increases in value if they outweigh changes in performance. Like the other inputs to the value equation, the costs are composed of a variety of different elements. For example, the costs relevant to the purchase decision could include acquisition cost, repair cost, maintenance cost, operating costs, salvage or resale costs, disposal costs, etc. The design of a system or product involves the principal task of evolving a form that can support the functions required by the system or product. The design must be optimized with regard to cost, technical requirements, and value considerations of the customer. DFX is a special case of DFM, where a certain area, say X, is selected for attention. Improvements in X are proposed after detailed analysis of the process by a team of cross-functional experts. The performance measures are established and items are identified that will simplify the process and at the same time provide value to the customer. Standard end products enable manufacturers to use make-to-stock market orientations, thereby decoupling manufacturing decisions from market transactions. Another way to bring customized products quickly is to use modular designs. In the fashion world, this is called mix and match clothing. In manufacturing, assemble-to-order systems allow the customer to specify a need, and then either the customer or the vendor selects pre-engineered sub-assemblies to meet a customer's need. Services can be classified on the basis of the degree of contact with the customer, like low degree of customer contact, high degree of customer contact. Services with a high degree of customer contact are difficult to control, as the customer can affect the time of demand, the exact nature of the service, and the quality or the perceived quality of the service. These types of services often require a high degree of personalization and speed of delivery. Product development strategy requires a capability of the organization to correctly evaluate product concepts so that there is support to design new products or to introduce product improvements in keeping with market requirements. Internal development has significant advantages, like the firm knows the product from a hands-on perspective. It understands the technologies used in the product. When the product fails or when related activities are discovered in the market, the firm can react quickly. The products tend to be unique, as the firm has created the technology and the product and so on. Reverse engineering is determining the technology embedded in a product through rigorous study of its attributes. It entails the acquisition of a product containing a technology that the company thinks is an asset, disassembling it and subjecting its component to a series of tests and engineering analysis to ascertain how it works and the engineering design criteria used in the product's creation. The internal and contracted out R&D is an ideal option for those who do not have the necessary facilities and expertise to carry out the work and yet would like to maintain control and own the results exclusively. It allows short-term access to world-class personnel and facilities that would normally be beyond the company's means. In a joint venture, two or more organizations form a separate legal undertaking, which is an independent organization for strategic purposes. The partnership is usually focused on a specific market objective. Producer-customer strategy is usually undertaken in the form of buying a piece of production machinery with embedded technology. This is perhaps the quickest form of technology transfer because the technology is already packaged and ready to use. Most firms do not manufacture all the systems that are required for the product. There are specialized firms that have the technology and designing capability to supply the system to the firm's specification. In some cases, subcontracting is used as a cost reduction option, as the cost of technology and development by subcontracting firms may be lower than that of the firm. Production systems can be classified as job shop, batch, mass, and continuous production systems. Job shop production are characterized by manufacturing of one or few quantity of products designed and produced as per the specification of customers within prefixed time and cost. The distinguishing feature of this is low volume and high variety of products. Batch production is a form of manufacturing in which the job passes through the functional departments in lots or batches, and each lot may have a different routing. It is characterized by the manufacture of limited number of products produced at regular intervals and stocked awaiting sales. Manufacture of discrete parts or assemblies using a continuous process are called mass production. This production system is justified by very large volume of production. The machines are arranged in a line or product layout. Product and process standardization exists and all output follow the same path. Production facilities are arranged as per the sequence of production operations from the first operations to the finished product. The items are made to flow through the sequence of operations through material handling devices such as conveyors, transfer devices, etc. Now let us check if we have understood the various concepts discussed in this lesson clearly. Goods are intangible products that are consumed as they are created. Right or wrong? Wrong. Licensing is when two or more organizations form a separate legal undertaking. Right or wrong? Wrong. Fast-to-market capability is the ability to design, develop, and introduce a new product quickly. Right or wrong? Right. Before we end, let us briefly revise what we have studied till so far. Products can be tangible or intangible. Tangible products are called goods, while intangible products include services and contracts. These are collectively referred to as products. Product development includes a number of processes in identifiable stages. These are clarification of the task, concept generation, embodiment design, detailed engineering design, and physical evaluation. Product design provides the operations team the basis for preparing plans for materials acquisition and production. Once the product is introduced, the organization needs to monitor customer satisfaction and detect product weaknesses so as to provide feedback to the design team. Concurrent engineering approach is to speed up the product development process, with an integration team ensuring the exchange of information between the teams working on different aspects. It is possible to considerably reduce development times and create high-quality product designs that meet customer expectations. Proper architecture is extremely important as it establishes the functional capabilities of the product, its features, and post-sale servicing needs. The capabilities of the product delivery system and post-sale support that the customer expects and determine the ability of the organization to provide for these and the roles and risks each player within the supply chain will assume. Some concepts related to good product design and architecture are design to cost, design for manufacturability, design for X, end product and part standardization, and modular designs. Services with a low degree of customer contact involve the same stages as the design of manufactured products. However, services with a high degree of customer contact normally require a much higher level of capacity relative to demand and also require greater flexibility. Different strategies are employed in product development. These are internal development, collaborative or R&D with networking, R&D contract or consulting engineers, licensing, joint venture, manufacturing subcontract or producer customer, acquisition of a company with technology, and reverse engineering.